Okay, so this is determination of an equilibrium constant for the iron thiocyanate equilibrium. And so it says the first part of part A, we are going to use solution 1, which is 0.2 molar iron nitrate in 0.5 molar nitric acid. It has to be dissolved in acid. Okay, and you can see I already put some in a beaker. And solution 3, which is 2.00 times 10 to the minus 4th molar potassium thiocyanate. And I've got that in this beaker. Okay, so we're using a lot of iron, 0.2 molar, and very small amount of thiocyanate. The reason for this is to drive the reaction, the equilibrium, all the way to the product, to the complex, so that way we can construct a calibration curve. Okay, so we have to make up solutions, and we're going to make up those solutions, and in these beakers that I've already labeled, and then we're going to put it into the test tube, and we're going to measure the absorbance of the colored compound in the Spec 20 spectrophotometer. Okay, so to prepare these 6 solutions, it says to pipette and use a pipette to add, to make the different mixtures here. Note also we have to make our own blank. We cannot use the just deionized water as a blank. We're going to have to make our blank this time. That's to calibrate the instrument. And so we're going to make these solutions as table 1 in the lab manual. If you look, for the iron, it's exactly 5 milliliters in all of them. So for the iron, I'm going to use a 5 milliliter volumetric pipette that you've used before. Okay, so you've used this kind of thing before. But for the other ones where I have to measure different amounts, I'm going to use what's called a graduated pipette. And I've got a couple of them here. Okay, so now the reason I have 2 of them is because there are 2 different types. Okay, the one over here on the that I'm holding in my hand that you can see now, if you read right up at the top, if I can bring it up here so you can see it, it says blow out. All right. So what this means is you can see here we've got a 0 line at the top, 9 milliliters is down here, and then it goes all the way out to the tip, that's 9.5. In order to get 10 milliliters out of here, you would use the pipette bulb to force the last little bit out. That is different than what we do for volumetric pipettes. Okay. It is also different for this graduated pipette. As you can see there, it does not say blowout on here. On this one, this type, you treat it just like a volumetric pipette. In order to get 10 milliliters out of here, you just let it drain out. You do not take the last little drop. So when you're using graduated pipettes, you have to be careful to look and note, does it tell you to blow out or not to blow out the tip to get to the last little bit out of there, to get to the exact 10 milliliters in this case for this graduated pipette. All right. Now, since we are not measuring 10 milliliters, we're measuring 1, 2, 3, 4, and 5. We can just go from, for example, if I wanted to measure 5 milliliters, I could go from 1 to 6. That would be 5 milliliters. So I don't have to worry about blowing it out or not blowing it out. Doesn't matter, right? But if I wanted to deliver 5 milliliters and I started at 5, on this one that does not say blowout, I'd go from 5 and just let it drain out and not blow it out. But if I use this one and I start at 5, to get to 10, I'd have to blow out that last little drop. That'll be in here. Okay. So, now the most important part here is not to get the exact values on the table. Since you're going to be measuring it, the main thing is to read off where you start, right? Where the meniscus is where you start and where it is at the end. So if you put in, for example, if I go to 2 to 4.1, I didn't measure 2 milliliters, I measured 2.10 milliliters. Or 2.05 if I didn't quite get to the 4.1, for example. So the most important thing is to read off the values Obviously, you want to get close to the values that we have in the lab manual, but doesn't need to be exact. Now, I'm going to go ahead and do all the pipetting since it doesn't pay for you to watch me pipette, and it's hard for me to video it anyway. But then you will get the data from your instructor for what the actual volumes are. Okay, so you can see that I've pipetted the requisite amounts into each of the beakers, and you can see that the color gets progressively darker as we get to 5 because there's more thiocyanate present, right? And so now that we have all the samples, I'm going to transfer them to the test tube here that I've got in the rack, and measure the absorbance on the Spec 20. Okay, so I'm ready to start taking measurements. I have to first calibrate our Spectronic 20 spectrophotometer, and with nothing in the sample compartment, right, I've already set the wavelength to 455 nanometers. That's our right thing, using the wavelength knob. So now I'm going to, with nothing in there, I need the transmittance to read 0 because there's a shutter. No light is getting through, so I have to adjust the 0% T knob until it reads 0. Okay, so it's reading. Okay, so it's reading 0. Now I would put in the blank so I know how much 100% of the light getting through is, and I adjust the 100% T knob to 100. But usually we use distilled water as our blank, but in this case, since our iron solution has a little bit of color to it, I have to use the blank that I made up. So I'm going to pour the blank into my test tube here. And then I'm going to wipe off the outside, make sure there's no fingerprints or anything on it. And then I'm going to line up the line with the little line on the sample compartment here. And now I have to get it to read 100. Okay, so it reads 100. Now I'm going to take the blank out, and I'm going to switch the mode over from transmittance to absorbance. Okay, now I need to read all my other 5 samples. And now I could use 5 test tubes, but I'm going to use the same test tube. I'm just going to rinse the test tube with the next solution. So I'm going to dump out the blank. And then I'm going to put in sample 1. So I'm just going to put in a little bit of the sample and use the sample to rinse the test tube a little bit, get any of the little bit that was the blank out of there, and dump that out. And now I'm going to fill it. Now the reason I can do this is because I've made up plenty of solution of each one, and this way I don't have to worry if there's a difference in the test tubes because I'm using the same one for all of it. Okay, so There's the absorbance for solution number 1. Now I'm going to repeat the process, dump out solution number 1, and try solution number 2. Again, I'm going to rinse it with a little bit of solution 2. And then I'm going to fill it with solution 2. I still have a little bit left. There's the absorbance for solution number 2. And we're just going to keep going here. There's the absorbance for solution number 3. There's the absorbance for solution number 4. One more to go. And there's the absorbance for solution number 5. And that concludes the data for part A. Okay, so now I'm getting ready to do part B, where this time I want an equilibrium mixture. Okay, I don't want to drive it all the way to products. So I'm going to use 2 solutions again, of the one of the iron nitrate, one of the potassium thiocyanate, but this time they're both 2.00 times 10 to the minus third molar. So they're roughly equal in concentration, or exactly equal in concentration. And again, I have to make up my blank, and this time I'm going to make up 3 different equilibrium mixtures, and then I will do the same thing as I did before. I'll transfer a test tube and then use the Spec 20 to measure the absorbance. So again, I'm not going to show you all the pipetting. I'm using cleaned and rinsed pipettes because I don't want any of the solutions from the previous part to interfere with this part. And so I won't record me doing all the pipetting, but I'll jump back in, show you the solutions, and then collect the data. Okay, so you can see I've made the solutions for part 2, and again they get darker as they go from 1 to 3 because again you've added more of the thiocyanate, and so now I just have to measure the absorbance at 455. Okay, so the Spec 20 should still be calibrated, but just to double check, I moved it back to transmittance. There's nothing in the sample holder, and it still reads 0. So now I'm going to put the blank in, the blank for part B, and we'll get that to 100%. So again, I've got my test tube here. It's been rinsed with some water, so I need to rinse it with the blank solution a little bit to get the water out, and then I'll refill it. Okay, so it's pretty close to 100 because the blank is not that much different, but it's a little bit of different amount of iron, so we're going to get this back to 100% transmittance. Okay, well, thought I had it. It's very touchy. Okay. Alright, now I move the mode to absorbance, and then I need to put my solutions into the test tube, and again, I'll rinse each one before I fill it. So here's solution number 1. Okay, so there's the absorbance for solution number 1 for part B. Now we're going to do solution number 2. And we're going to rinse. And there's the absorbance value for solution number 2. Now we've got solution number 3. Forgot to rinse. Hopefully I have enough. That should be enough. And there's the absorbance for solution number 3 for part B.